next one we are going to see the stack implementation using singly linked list. So we can implement the stack using array and using linked list also. So if you are going for the static for the implementation, we will go for the array. If you are going for the dynamic implementation, we just need to implement the stack using the linked list. So while using the linked list or the array, the main concept of the stack is same, which is last in first out. Which one is inserted as the last, which will come first. Okay, so the implementation of stack, but in terms of array means we just visualize stack as the bucket. But if you are going for the linked list, in the sense we will implement that with the address also, because linked list will hold the next value as the address of the next element. So we have the connection with the last element with the next element which is inserted. Last element in the sense the element present at the end of the stack. End of the stack in the sense which is inserted as the first of the stack. So a next element is inserted means we need to make that the next element should point to the previous element. So in this way only we are having the implementation as a linked list, and the top pointer will point to the recently inserted element. Okay, so the recently inserted element, once 11 is inserted means that 5000 is pointed by the top. After the 22 inserted, this 11th element is pointed by the 22, and 5000 in the sense that 22 49 4900 it is pointed by the 33. So each and every time while the element is added to the stack, the top will be initialized, or the top will be modified with the recently inserted element item. So similarly in the stack operations also we are having the as such what we have seen in the array. Here also we are having push, pop and peek and display, but the implementation point of view this will vary. So while you are initializing the push, the initializing node, a node will consist of two things, one the data and the next pointer. So while you are initializing, we need to create the new node, and then that new node is it is not the current node in the sense which is not null means you can insert that element. If the memory allocation for the new node is failed means the tag cannot be, the element cannot be inserted into the stack. So that's why we are displaying at the overflow. Otherwise we can make that head here head is pointing referring the top element. So the new element next is pointing to the head. Okay, that head will become the new node, which means that in the stack in the previous one, if the 44 is inserted previously, this top is in the for 8400 and sorry 4800 is pointed by the top. While the 44 is inserted, this 44 will now pointing to this head, then this head will become the new node that is represented here. Okay, similarly for the pop operation, if the stack is empty in the sense that is under flow, while we are doing the deletion we just need to make the pointing of head to the head tends to next, but we need to we need to delete the address which is pointed by the head previously. That's why we are maintaining the temporary variable to hold the head. After the head is pointed to the head tends to next, it is implemented as the delete temp. Okay, then for the peek operation we just return the head. As such what you have seen in the array, we are having only the head element, that is the peek operation. For the display we just need to start from the head to the previous elements. Using the next pointer we need to do the display operations. For the pop, push and peek the operation is O of 1, and for the display we need to traverse up to the last pointer. So the space for the stack is O of n. Okay, while you are implementing the stack using linked list, we will have the dynamic memory allocation and efficient memory usage, because while you are going for the static implementation, we don't have the exact number of elements to be inserted into the stack. That's why the efficient memory usage done in the singly linked list, because when we need to insert an element, at that time only the new memory is allotted, and the implementation is also easy comparing to the array. While you are using the pointer, this will somewhat complicated, but while you are using single linked list we are using, because we don't go for the doubly linked list or circular linked list. So that's why the implementation in terms of linked list, it is easy, and the versatile also. Versatile in the sense it is easy to implement like other data structures, queues and the trees. Okay, so the real time examples of function call, undo and redo, and browser history, all those operations, all those examples what you have seen in the array, that is similar to the linked pointer also, because everything is we are seeing, we are just expressing the stack, but the implementation is somewhat different comparing to the linked list and the array. So the linked list, we must know what is the linked list first, then only we can understand how we are implementing that stack using the linked list. The linked list in the sense chain of elements, each element is pointing to the next element through the pointer. When we are making the link between two nodes, means one node address is pointed by the second node. So for the linked list, the data member is node and the data and the next pointer. The universal implementation is node data and the next only. Always when we are making one element to the next element of the linked list, means we just need to point that next to the newly inserted element. So this is dynamic memory allocation, because you are using the pointers. Once a node is inserted, once we need to insert a node into the stack or any kind of data structures, at that time only we are implementing, we are including the we are allocating the memory. So as a whole, the stack is a single point of contact, while only one point will be used for the insertion and deletion. That will also used for the displaying of all the elements. Once the element is popped out from the stack, then only we can display the element, we display the stack element. But not only we don't need to pop all the elements from the array. In this array we can go to up to 0th index, and for the linked list operation we can go up to the first pointer, which doesn't which the until the pointer having the value. So all those operations are time complexity is of 1 only, and the space is reduced in the linked list comparing to the array. So we can go for both kind of implementation. If you are going for the static implementation, is we need to express in terms of array. If you are going for the dynamic implementation, means we can go for the linked list. So singly linked list is used for the stack implementation. Other than that, according to the stack, where the operations which has only one point of insertion and deletion, means you can go for the stack. If it needs to process more than one, for example, one side of insertion, one side of deletion, means you can go for the stack. So in the next kind of videos, we will see what is the queue and how we are implementing this queue. And before that, we will see what is a stack application. In the first video itself, we have seen the insertion, deletion and the display and peak with the infix to postfix conversion. The clear explanation of the application, we will have the stack.